Hello, 8th graders. At the forces matrix and looking at objective 1, which is to demonstrate and calculate how unbalanced forces change speed and direction. As you go through the presentation, you will see the blue circle with question marks on it on different slides. You will need to answer each of these questions on the back of your Wix document. At the conclusion of this video, you can go back and look back at this information if you need to. So let's take a look. May the force be with you. So what is a force? A force is any push or pull on an object. This force, any force, is measured in newtons, which is represented by a capital N. A force is required to make a change in the object's motion in any way. So, like a push or a pull. Some examples of some forces would be gravity, magnetism, and friction. Think about, as you're going through this, which one of these three forces will work against motion. And remember that this will be your first question on the back of your Wix document at the end. So let's look at vectors. A vector is simply an arrow which indicates the direction and the size of the force. As you can see in the picture, you have the direction moving to the right with the red arrow. Below that, a blue, thicker line moving to the right as well, which indicates magnitude or the amount. Sometimes you may notice in different documents that there is a wider arrow, which may also indicate a greater force. Two types of forces to consider. Balance forces, which are equal forces acting on an object in opposite directions. Look at the giraffe picture, for example. You have the giraffe pushing downward on the ground and the ground pushing upward on the giraffe. These forces are balanced, which is why the giraffe is not flying off into the air. Look at the two people playing tug of war. Notice the arrows in opposite directions, but yet that neither is pulling more towards the other because these are balanced. They have an equal amount of force applied to the rope. Motion will not change when the forces are balanced. Balance forces don't affect the motion. On the first picture on your left, you see the character with the rope pulling at 50 newtons and the one on the right pulling at 50 newtons. Will the people move in this particular example? Remember, equal forces do not create motion. The bird's on the right. The bird is flying to the right, and the amount of wind resistance or air resistance is equal at 100 newtons each. Think about, will this cause a change in the motion? So you notice at the bottom of the screen that the question is asking about net force. Net force is the total amount of force acting on an object. In the first picture, you notice there are 50 newtons pulling to the left and 50 newtons pulling to the right. That is a net force of 0 because it is an equal amount in both directions. The picture on the right is also 100 newtons on both arrows. Therefore, it is also a net force of 0 newtons. The second type of force is an unbalanced force. Unequal forces acting in the same or different directions which do cause a change in an object's motion. For example, starting and going off from a starting line is going to cause a change in motion. Stopping also changes the motion. And turning or changing direction will also create an unbalanced force. Unbalanced forces do affect the motion of the object. If you look at the first picture, there is one person pulling at 50 newtons of force, and 3 people on the right pulling at 100 newtons of force. These two forces are unbalanced and should cause a change in the motion. Looking at the picture on the right, you have a force of 100 newtons of the bird and an upward force of 50 newtons. Again, these forces are not equal and therefore are unbalanced and will cause a change in the motion. Unbalanced forces affect velocity. So let's take a look at what this graph would mean to us in this case. This graph represents how we represent unbalanced forces on an actual data point graph. If you look at the first point, where we have position in meters and time in seconds, at the 1 second mark, the position of the line is at 20 meters. Because the line is staying at a constant rate at 20 meters, it is considered a balanced force. If you look at the second part of the line, which is right here between 1 and 3 seconds, the line changes from 20 meters to 60 meters. Because there is a change in this represents an unbalanced force. The reason this represents an unbalanced force is because there is a change in direction. We went from 20 meters to 60 meters. The third part of the line segment, you'll notice, is between 3 and 4.5 seconds. And you'll notice this line has stayed at 60 meters. And because there is no change in this direction, it is a balanced force. Looking at the last part of the line segment coming down between 4.5 and 6 seconds, the position is going from 60 meters to 20 meters. Because of that, that is a change in direction, which creates an unbalanced force. So to recap, we know that we have a balanced force at the first part of the line, line segment A, an unbalanced force, line segment B, balanced, line segment C, and unbalanced, line segment D. Notice again, there is another set of question marks in the blue circle. Keep in mind you need to come back to these on each individual slide and answer them on the back of your Wix document at the end of this presentation. Okay, at this point I would like for you to turn your paper over from your Wix document that is set up, and I would like you to answer the questions that are in the PowerPoint presentation on the question marks, which are going to be 7 questions. In addition to that, when you're finished, you will come back, preview the video of the skydiver representing unbalanced and balanced forces, and then answer those 3 questions as well. A total of 10 questions on the back of your document. Now watch this short video clip on skydiving, paying close attention to what's happening in the video, and go back to the questions at the end and answer the 3 remaining questions on the back of your Wix document.
When a skydiver jumps out of a plane at 3,000 meters, her speed goes through some big changes. So what's happening to the forces as you fall through the air? The force of gravity is always trying to pull us towards the Earth. Before the skydiver jumps, the floor of the plane provides a counterforce, which balances the downward force of gravity, right up until the moment she steps out. Gravity immediately pulls her towards the ground, and she starts to accelerate downwards. But air resistance is acting in the opposite direction. The faster she falls, the greater the air resistance. Eventually, the upward force of the air equals the downward force of gravity. When forces are balanced, the speed remains constant. That doesn't mean she stopped falling. It means she stopped accelerating. She's still doing a steady 55 meters per second, and hitting the ground at this speed isn't a good idea. To slow down, the upward force needs to be greater than the downward force.
Front office, Emily, we're
The forces are no longer balanced, and this changes her speed. She slows down. Because she's slowing down, air resistance decreases until it balances gravity again, and she reaches a much slower constant speed. Approaching the ground at 5 meters per second is a much better idea. As she hits the ground, there's a thumping great counterforce from the Earth, which decelerates her very quickly. So for skydivers to land safely, they need to understand forces and use air resistance to slow themselves down.
Okay, so hopefully you enjoyed the skydiving video and helped bridge your understanding of unbalanced and balanced forces a little bit more. Now that you have finished all of the wicks and watched the video, now you need to go back to the different slides throughout the presentation, answering questions 1 through 7, and I've given you the slides there so that you know where to go back and look. Questions 8, 9, and 10 come specifically from the video that you just previewed. Go ahead and please answer these questions on the back of your Wix document.